Hey there, this is Andrew, and welcome back to another episode of Bridging to a 7, where we discuss some of the hardest exam questions that can show up on your paper. Today, we're going to focus on binomial expansion. We're given the first three terms of the expansion of 1 plus ax to the n, and we are asked to find the values of a and n. Right off the bat, we are asked to find the value of two unknowns. And we are given two pieces of information that we can use. This means that we can form two equations and then solve simultaneously to get the value of a and of n. So let's first off get the coefficient of x. In the expansion of 1 plus ax to the n, the coefficient of x is going to be n chooses 1, 1 to the n minus 1, ax to the 1. This is going to give you the term in x. N chooses 1 is equal to n. How many ways can you choose one item from n items? N ways. 1 to the n minus 1 is equal to 1. Ax to the power of 1 is ax. Therefore, the coefficient of x is na. And we know that na has to be equal to 6. So this is your first equation. We now need to form a second equation using the coefficient of x squared. The coefficient of x squared is going to be n chooses 2, 1 to the power of n minus 2 times ax squared. This is going to give you the term in x squared. N chooses 2 may be a bit harder to simplify. We should use the definition of combination. So n chooses k is equal to n factorial divided by k factorial times n minus k factorial. In this case, k is equal to 2. Therefore, n chooses 2 is equal to n factorial divided by 2 factorial times n minus 2 factorial. 1 to the power of n minus 2 has to be equal to 1. Ax squared is going to give you a squared x squared. Let's simplify this factorial a bit better. N factorial can be written as n times n minus 1 times n minus 2 factorial. The reason we want to stop here is because we want to cancel the n minus 2 factorial in the denominator. Two factorial is 2 times 1, or 2. And we know that the coefficient of the term in x squared is equal to 16. So this is going to be your second equation. Now we need to solve them simultaneously. Let's start with a more complicated equation. I hate fractions, so I am going to multiply both sides of the equation by 2. Expand and simplify the left-hand side. We're given that a times n is equal to 6. So we want to make a times n appear as much as possible. A squared, n squared. This is an squared. A squared times n. We can split up the a squared into a times a, so that we get the an together. An is equal to 6. From here, we can solve for a readily. Since an is equal to 6, we can just plug in the value of a we just obtained to find the value of n. Therefore, a is equal to 2/3 and n is equal to 9. And this is the end of the question.